the Exploration Systems Mission Directorate, also at NASA headquarters. And in this one-hour session, which is being live streamed on the LPI YouTube channel, these presenters will speak for around 30 minutes and then be able to do questions and hopefully answers for the rest of the time. To ask a question, you can enter it into the Zoom Q&A feature at the bottom of the screen. Please identify yourself and your affiliation. Tell us how you want to direct the question. And Dr. Deborah Needham is going to be moderating the Q&A. So please note that this session is being recorded, and hope you enjoy the opportunity.
Hey, thank you, Eileen. And thank you everybody for attending today. Sarah and I are going to discuss kind of our current status on developing science participation in the Artemis missions to the moon. This really is an exciting time. What we want to talk about over the next hour is an exciting topic. This is our generation's opportunity to send astronauts elsewhere off the Earth beyond low Earth orbit. It's the start of a journey. It's not a single mission. It's not a single event. This is a start of a long journey. All of you are here at the beginning with us. And what we want to talk about is an opportunity to participate. So that's what we're here to discuss today. So we'll go through a few slides, give some of the background content, and explain some of the announcements that have come out recently. But I think one of the most important things to see here today, you know, Sarah and I are in two different mission directorates, but we're working together. And it's not just Sarah and I, it's a huge team of people who are working together to ensure that as we send astronauts out to explore the solar system, starting with the moon, we have science along for the ride. Technology, science, research, that's what we're talking about here. And we need all of you to help us with that. And this is, again, an adventurous journey that we're getting ready to undertake. So with that, we're getting very close to our first step on that path. Right now, we're getting ready next week, March 17th, for the rollout of Artemis 1. I was down at the Cape 2 weeks ago. I can verify that this SLS and Orion is a very impressive vehicle to see. I recommend, if you have an opportunity, to swing by the Cape at some point while it's either out for wet dress rehearsal, or even if it's out there getting ready to launch, go take a look. This is an impressive sight. Artemis 1 will be our test flight, testing out the systems robotically to make sure that we can safely take our astronauts out to the moon. So this is, again, one of those first steps, a big step for us on this journey that we're taking. And Artemis 1 will give us that opportunity to start looking at how we tie science in to the missions that will follow. Just a quick look at what Artemis will do. Artemis will depart the Earth. The vehicle will then be put into orbit around the moon. Depending on when we launch, we'll either orbit the moon for a half orbit or for 1.5 orbits in our distant retrograde orbit. Again, the main objective of Artemis 1 is to test out the systems. But while we do that, we will be carrying an array of scientific experiments with it. I know folks sitting here in the audience are participating in some of the CubeSat missions that will be going, some understanding the radiation environment from the sun that our astronauts will be experiencing during Artemis missions, some studying the moon itself. I'm sure there are a number of abstracts and discussions here at LPSC this week talking about those. So please do take your opportunity to hear about that and learn a little more about what's going there on the CubeSats. We also have some CubeSats that are focused on understanding how life responds to that radiation environment, as well as some that are learning about how to navigate and travel in deep space. So we do have a pretty exciting set of experiments from our CubeSats, as well as some experiments inside the Orion itself. We'll be doing a lot of work trying to understand what that radiation environment is like inside the Orion vehicle, so that we can ensure that we keep our astronauts as safe as we can. The duration of this Artemis 1 mission, depending on when we launch, will range from anywhere between 26 and 42 days. The launch windows do have an impact on how long the mission will last. But even at the shorter end of that, we'll be able to collect the critical information we need to ensure that we can follow on with Artemis 2 and Artemis 3. Now, we're mentioning the Artemis activities here. I do want to mention one other activity that we have coming up very soon. In mid-April, April 15th, we will be launching a crew that includes some of our previously announced Artemis astronauts up to the International Space Station. Of particular interest, I think, to our community here is one of our own is going to be on that flight, astronaut Jessica Watkins, planetary scientist, geologist. And I must say, it is a pleasure to know that we've got a good scientist going up there, but also to point out that the astronauts that are riding along with her have all gone through a certain level of science training themselves. The entire astronaut group at this point are strong advocates for utilization for science. And I think that's a testament to them understanding the exciting work that we're doing, and their willingness to work with us to ensure that they can accomplish the objectives that our community has. They very well know that they are kind of the tip of a spear, of which we are all a part of, as we try to conduct this research and understand our Earth, our moon, the planets, the solar system, the universe within which we reside. This just shows some of the activities that we have underway across Artemis. Artemis 1 will be testing the Space Launch System and the Orion spacecraft, but also in various stages of development at this point, we have a human landing system. We're working through our surface operations. We're developing the gateway to orbit the moon and support surface operations. All of these are in various levels of going out for competition. We do have selected Spacex as our option A for the Artemis 3 landing. So that will be our first human landing system test, working in collaboration with Spacex. Gateway has several elements that are now in development and will be delivered throughout the first several Artemis missions to build up that outpost in orbit, which will help us support surface activities and gain us access to areas outside of only the polar region. We're developing new concepts for surface mobility, as well as spacesuits to support this new adventure to the moon into lunar orbit. These suits will give us an ability to conduct surface operations, as well as operations out in the space environment. We're looking at announcements. That competition went out last year. They're still in final stages of review right now, but we expect an announcement out on those systems here in the next month or so. We're also working towards an RFP on surface mobility for our lunar terrain vehicle. So we're expecting to put an RFP out on the road sometime in the next few months. So pay attention to that. I'm often asked, what are the capabilities of these systems? And I can only point to the RFPs that we put out, which is where we document the requirements that we would like to see on these systems. It's up to the creativity, the ingenuity of our commercial partners to tell us how to do that best. So we'll review those proposals, and that's how we decide on selecting those teams. So do pay attention to these RFPs. That's where we document the requirements that are open for that competition. Ultimately, what we're looking at is landing on the moon for Artemis 3. That will be our first landing in the South Polar region, which I think most of you understand, and all of us are continuing to understand in more detail just how complicated that terrain will be with the lighting environment. It is not like the Apollo landings in the more equatorial region. The ratio of light to dark, equatorial region, it was very consistent and predictable. But in the polar regions, the ratio is not always 50-50. You can range anywhere from permanent darkness to nearly permanent light. And what's even more difficult to deal with is that in short surface distances, that ratio can change drastically. So there's a significant amount of planning and modeling and trying to understand that environment within which we plan to operate. Again, this is not simply returning to the moon. This is boldly exploring a new area that we've never been to. And it will require new and creative approaches. And again, that's why we are leaning so heavily on our commercial partners to really drive that creativity and ingenuity for us. We'll set the requirements, but we need that partnership to move forward. Ultimately, as we land more on the moon, we'll begin building up what we refer to as a base camp situation. So we'll have more and more infrastructure in place. We're still working out the details on exactly what that looks like. And again, we'll lend and lean on our partners to help us figure out what that looks like in more of an end state as we move forward. But that kind of is an overview of where we are right now with Artemis. Now, the key is the partnership that we have with our Science Mission Directorate. Science Mission Directorate is exploring the moon more globally. You heard Joel speak yesterday about the CLIPS missions, the CLIPS landings. But we are partnering heavily on how do we do as much science as we can in the polar region as well. And so I think with that, I'll hand over to Sarah, who will talk a little more.
Awesome. Yes, so it's been 50 years since we've had humans doing science on the surface of a planetary body. It's about time we did some more. Looking forward to it. I hope everybody in the room is excited about this opportunity. I want to stress that Artemis and Apollo are different, though, right? For a number of reasons. First of all, we are not starting from scratch, right? We're building on Apollo. We're building on even Constellation and all of the planning that we have been doing over the last 50 years repeatedly to get to this point. And so none of that has been wasted, and we are standing on the shoulders of giants, as they say. So we've got that going for us. Also, the lunar science community is different. I mean, look around this room, right? This is we have a really vibrant, wonderful lunar science community that has been thinking about these problems now for 50 years. We've got new data that we've been analyzing from orbit. We've got these new CLIPS missions coming along that are going to provide new data. So, we are starting from a different place scientifically as well. NASA is also different in a couple of ways. First, we have actually a large cadre of talented lunar scientists that are among our civil servants in our NASA workforce. It's something they didn't really have in Apollo. There were just a handful in those days. But now we are embedded. We're embedded in every layer of Artemis planning from the beginning, right? We're not an afterthought. Science is at the table. We're sitting in those meetings, making sure that somebody is speaking up for science as all of these planning is happening, as all of these systems are being developed. There's somebody in the room that can stand up and say, hey, that's not going to work for us. Let's find another way. And so thank you all to those of you, the NASA folks that have been sitting through a lot of very long, boring meetings and reading a lot of very long, boring documents to make sure that the science community's needs are able to be met. And they've been doing this for years. Jake was just talking about the training that astronauts are doing. And the reason that they have this geologic training is because we have spent years building up relationships and making sure with the astronaut office and making sure that they understand what we want to do and why we want to do it. And that is an amazing head start that we also didn't have during Apollo. And also Jake talked a little bit about how our approach is very different than it was during Apollo. Is much more commercial. We're working really well with all of our commercial partners. And it's a different way of assembling all of these pieces together. We are going out and competing many of them rather than building them in-house at NASA. And that sort of changes the way that we operate. It changes the way that we can interact with the community. And sometimes that makes it harder, but hopefully it will make it more sustainable in the end. We're also working closely with a lot of our international partners in ways that we didn't necessarily during Apollo, with the European community, with the Japanese, the Canadians, and bringing them along, to fill in some of our holes as well. And so that's really exciting. Because the moon is for all of us. And so it's great that we can explore it together. We've now sort of reached this transition point. I'm sure a lot of you noticed that when we put out roses this year, there were a number of new placeholders for calls in there, including the Artemis geology team, which we will talk about in just a minute. The overall Artemis science team, though, is going to be composed of both a mixture of competed roles as well as assigned roles. And so I'm going to talk a little bit more about what that structure is going to look like. And I do want to say that this is all a work in progress. We are putting our cards on the table. We're striving to be as open and transparent with you guys as we can be. Sometimes that means you get to see a little bit of the sausage making. So I appreciate your patience as we're sort of working these things out in real time, but it's always my goal is to be as open and transparent as I can be with you guys so you know where we're going and have the most opportunities. Just want to talk a little bit about a couple of these solicitations that are now sort of on the streets, just the placeholders. I admit we haven't written the full call yet, so but these placeholders are out. We do intend to put out those calls this Rose's year. That's why we stuck those placeholders in. You can see there that this one for the Artemis 3 geology team, first of all, I want to note that this is specifically for Artemis 3. We do intend to put out a different call for a different geology team for Artemis 5 and for each of the subsequent sorties. At some point when we sort of transition to a more sustained phase where we're going back to the same place over and over again, it probably looks for a different structure for a team. And so we're going to think about how we want to structure that. But when we're in this sortie phase, at least, we intend to have a separate call for each mission. And this geology team is going to interface with other members of the overall Artemis science team, including the NASA internal team, as we will talk about in a minute, as well as deployed instrument teams as we bring those on board. And we do expect to also have a participating scientist call as we get closer to launch. Let's see. Other things that confused people as I put this out, the most questions I've gotten about is that last sentence about the team size is expected to be of order of 10 members. That's not meant to be a hard and fast thing. I just wanted to, I know folks are already out there forming teams, and I just wanted to give you some sense of scale. If you form a team of 3 people, that's probably not going to cut it. If you send me something with 24 co-Is, that's probably not going to be what we're looking for anyway. But 10 is not meant to be any kind of hard and fast number. We do expect student participation. We always enjoy having students around as well. And we do intend to select a single proposal from those submitted. So this will be the one call that we have for the Artemis science team, but there will be a participating scientist call, as I said. So if you don't get selected, you're not out of luck. You have a second chance to propose. Just a few words about the deployed instrument call. I will note that it says that these are for the first landing. And we're actually thinking now that it'll probably be a little bit more for the first and second, third, whatever. We're still, as Jake said, not entirely sure what our capabilities are going to be with HLS. And so as long as we're in sort of flux, we want to try to get these instruments on board and start building them. We may not be able to fit them all on the first mission. They may have to go on the second. These sorts of things are still being worked out and negotiated, but we know it takes time to build these instruments. And so we want to get this call out to get people up and running as soon as we are able to. These deployed instruments will be expected to address the scientific objectives that we outlined on the Artemis science plan in the Artemis 3 SDT report. Okay, so let's talk a little bit about the structure of the Artemis 3 science team. So there's actually sort of 3 legs to this stool. There will be this Artemis internal science team. Again, these are NASA scientists that are already working, that in many cases have been working for years with Artemis. Currently, these folks are funded mostly through the human exploration side of the house, but we are transitioning them to fund them out of the science side. And these guys are the ones that will be underneath the firewall. So they will not be eligible to compete for these competed roles. And so if you have asked some of these folks to compete and they have quietly shied away, that may be the reason why. It's not that they don't like you. There will also, again, be these competitively selected teams. So the 10-member team that I was speaking about, as well as participating scientists. And then there will be the payload teams. And so we'll put out this call for Artemis 3-5 payloads. Eventually, there will be a call for payloads for the LTV. LTV is not expected to be available for Artemis 3, but eventually down the road, we will want to have that instrumented. So a little bit of explanation of what the roles are of this internal team versus the competed team. So the internal team has 3 basic functions, and they're sort of vary in time. So right now, the most important function they're serving is the one that we've been talking about, right? They are there to make sure that the architecture and the systems that are being built support science. They're embedded on these boards. They're reviewing all of the documents. They are the ones in the room fighting for you, fighting for your science. And they're also responding to requests across the agency. You know, when the agency wants to know, is it okay if we build the tools out of this material or that material? Is it okay if we do this? They're the ones that respond to those questions and make sure that the right information is getting out. As we move into this next phase, as we get the science teams on board, the second bullet, they will interface between NASA and those competed teams, right? And so they are sort of what Jake and I have been referring to them as the ball bearings between the machinery of NASA and the science team that's coming on board. They're your interface, they're your route in to make sure that you understand what's going on and can make the right decisions. They'll be leading the classroom, the field, the training ops for the crew. They'll also be leading the operational training for the science team. And you guys have to learn how to sit console in the science back room. And so they will help with that. And then their third function, as we move forward from mission to mission, is that they're there to provide that sort of mission to mission continuity, right? And to sort of serve the role as these teams come in for their individual sortie, to make sure that we are answering the needs of all of the community and not just the folks on that specific team. But is everybody getting the samples they need? If we didn't get that objective met in the first mission, are we going to meet it in the second? And so they're there to provide that mission to mission stuff. The competed team, on the other hand, will be focused on their specific sortie. They're there to develop the science objectives, the field science goals, the traverse planning, the sample strategy for that sortie. They'll support the training, the real-time ops, of course. They'll do the preliminary exam of the samples, get that catalog made so that we can get those samples out to the rest of the community. And of course, the post-mission geology report. And, you know, science. So a little bit more about this internal science team. We've got Jake and I are sort of the science leads here from the science and exploration sides. And then we've got folks who are looking at training and ops, the folks who are looking at samples, making sure that we're ready in the curation office to take those samples, making sure that contamination control and contamination knowledge are being taken care of. We've got planning and data folks who are, making sure that we have the spatial information, that the guys who are planning landing sites have all the right data that they need, the best data, to make sure that we have the software developed for the science team so that everything works smoothly and we can all get our data. And then we've got a payload integration officer who will work with those deployed payloads to be their interface to NASA and make sure that they are meeting all of the requirements that NASA puts on payloads that interact with humans. And we've identified most of these folks. There are a couple of them in the room here, and there are a couple more online. Not everybody could join us today, but many of them are here. We have one still whole. We do not yet have a contamination control scientist. We're working on that at the moment. Barb is sort of covering both roles, and bless her for that. We're still working on trying to fill that one hole, but for the moment, it's covered between the rest of them. So Cindy, Kelsey, Trevor, these guys have been working forever, making sure that our astronauts get the right geology training. They're also making sure that the hardware that's being built is the right tools for our astronauts for those needs. Sam, Noah, Matt, these are your data guys. Nobody knows that LRO data set like Noah does. So it's a great group of people. I'm really happy that they have all agreed to do this. And so if you see them around, thank them for their many, many years of effort. These are not, of course, the only civil servants that are, or NASA folks that are working on Artemis. It's actually quite a few other folks that have helped us out over the months, over the years. We've put these folks under the firewall so that they can't compete. Other folks will be able to compete. So if you have folks that you want to have on your team from NASA centers, there are plenty of good scientists out there. And we hope that we continue to have the support from them as we go along too. It's not just these 9 people. Oh, and I'm going to turn it back to Jay.
Thanks, Sarah. So a little more background detail so we can explain a little more about what has been announced thus far. She mentioned some of the activities that we already have underway, working with astronauts, working across and working with our engineering teams. One of those aspects is making sure that our astronauts are well trained from a science perspective. Not all of them are planetary scientists who have spent years going to LPSC in graduate school. So we'd like to bring them up to speed as much as we can. And so that includes not just training them at the last minute to pick up the right rocks on the moon. It's not, I think you all know, that's not how science works. You can't just learn it all at the last second. So what we try to do is an integrated approach that actually matches up with the other training cycles on the human exploration side. And so we break this down into phases that match up with our EVA partners. So we have an initial training phase that we are integrated in with the astronaut candidate phase. So they have the 2 years of training together as a class. And so we make sure that during that time period, we have training that is fully integrated in with that 2-year training cycle. After that, we have a phase 2 we refer to as intermediate training. And this is basically kind of, what are they doing between that initial 2-year training phase and when they do get assigned to fly on a mission. That could be an ISS mission. It could be a commercial crew mission. It could be an Artemis mission to the lunar surface or lunar orbit. Regardless, we want to make sure that they're all trained to that same level, and that during the time period between the initial training and their assignment, we kind of keep that up. We don't want to talk to them for a few weeks and then not talk to them again for 3 years and then try to cram a bunch of stuff in at the end. So that's kind of how we have that set up. And then phase 3 is when we start looking at assigned crew members. So for the phase 3, you maybe noticed a few months ago, we announced an Artemis group, an Artemis team. So we are starting to think about who are the astronauts that we will look to for some of the Artemis mission. We're now supporting commercial crew, low Earth orbit activities with the ISS, as well as looking forward to the Artemis activities. So you can see there's kind of a full plate there interacting with the crew branch. So we have to make sure that we've got the right folks, but we are starting to narrow down who's kind of focusing in on which activity. And so then phase 3 would be once we know someone is going to be assigned to an Artemis flight and working with the science team that we've competitively selected, we'll identify some of the content that is specific to the mission that they're being assigned to. And so that's where we'll be able to interject that content. This with Sarah.
Yeah, so we've been working on sort of doing better job of coordinating analog activities within NASA. So we have a lot of immediate and long-term questions that really require data. So we want to get out and do some analog activities, to figure out some of those answers. And so we recently asked League to outline our current analog objectives. And I want to thank the members of, I don't know if a few of you are in the room, and the members of the AOA SAT, the Artemis Objective SAT, who have sort of compiled all of the important things that we really need to get out in the field and test to get ready for Artemis. That report is now up on the League website. You should check it out if you have a chance. And that's what we will be pulling from as we go about the next few years of our analog activities, everything from desert rats and Nemo to things out in the rock yard, to make sure that we can gather the data that we need to be ready for Artemis. We also put out an annual Roses call for science team members for that, which I think is later, right? That's not the next slide. Yeah.
So before we talk about that, just wanted to explain some of those activities that are actually going on so we can talk about how we can ramp in participation. And so over the last year, we did conduct a number of testing activities. Despite some of the COVID difficulties, we have had a number of tests going on, and there's a variety and range of tests. Many of you might be familiar with some activities like desert rats or Nemo, especially tracing back to the Constellation era. Some of that is still ongoing. We have integrated tests that look at multiple components and elements. How do you conduct the operations with those constraints applied from the hardware? But we also can break that down into much smaller focus tests. tests that are really trying to narrow down to single variables and understand the trades that we would need to assess to make good decisions so that we can do the best science we can. So over the last year, we did in fact get a number of tests in Rockyard. We did have a kind of a learn how to do it again kind of test out in Arizona, trying to get our feet under us, working at some of the simulation activities down at the Johnson Space Center. So there's a number of activities going on that we're trying to ramp ourselves up in prepping for the Artemis activities we're going to need to do over the next several years. Looking forward at 2022, we do have a number of activities going on. Again, working the Rockyard, testing suits and tools, as Sarah mentioned earlier, making sure we get the right tool design, understanding how to build the tools to make sure that we're not contaminating samples and we're able to curate them the way that we want to, preserve those samples for science for decades moving forward. That includes, how do you do that with the suit on? How do you do that with various communications limitations that you have to deal with bandwidth issues? I think most of you understand from working science missions, you know, there are a lot of trades you have to work out early on in order to develop the system the way that you need it to work. We do have some analog activities in partnership with SMD going on in various locations around the country, including places like Iceland, learning how to core and collect samples in icy terrains. If you remember, one of the reasons that we are going to the South Polar region with Artemis is because we believe there to be volatiles there that we can gain access to. So we want to learn how to do that correctly. That's different than what we did during Apollo. We have learned a lot from Apollo. We're learning from ANGSA right now about how that process worked. But again, the South Polar region will be a unique environment that we have not operated in the past. Off to the right, you can see some of the activities. We'll be out in Arizona again, starting to look at integrated tests that bring in multiple components. How do we actually move around and do the operations we need? How do we deal with the lighting? What is it like to operate in a largely dark environment that has the sun just above the horizon, sometimes staring you right in the face in the direction you'd like to go? You look back to Apollo 12 is probably our best analog for understanding that. But even that had the sun several degrees higher than what we will see as the highest the sun will be above the horizon when we're at the South Polar region. So there's a lot to learn there. These are the things that we have underway. Again, trying to build the on-ramps so that Sarah can bring you know, the community into this. We do not want to do all this work behind firewalls. And our goal here is to increase participation from all of you. And so trying to explain what we have going on.
Yeah, so we actually need your help with this, right? So I've put out this call. There was a call that went out last year. We've gotten proposals in there in review, but there'll be another call that has gone out this year to bring in some of you folks to sit in that back room and help us understand what that science back room is going to look like. How is it going to be structured? How is the comms going to be structured? Do we have the right software tools? And we got to test these things out. And so we are planning to do it through Desert Rats. There may be other Artemis specific activities that we do as well to try and work through some of these problems before we get to the moon. And so if you're interested in being a member of that science team, of sitting in that back room and helping us figure out some of these problems, this is the program you can apply to help us out with that too. And it actually, I just should note that we even allow grad students, senior grad students, to apply to this program. No undergrads, thank you. But senior grad students can even apply to this program as well. Up and comers out there as well into the field. And I think that's our last. I believe that's our last slide. Oh no, one more. One more way for the community to participate. In fact, I know many of you have been to a lot of our LSSW Lunar Surface Science Workshop series over the last 2 years. Appreciate all of your participation. Some of you may never have heard of this before. If you haven't, we've been doing these sort of monthly series of workshops for the lunar community. This is the main way that Jake and I have been getting input from the community, and these are really important. We really are holding these things because we need input from the community, and this is the best way we can get it. And so please show up, please participate in these if you have an interest in the topic. All of those reports and all of those talks are archived. Thank you to the survey folks for that. So you can go to the survey LSSW website and find all of them there. We also realize that this is a two-way conversation. And so about once a year, we did it in May of 2020, last April, and we are planning this year again in hopefully May 10th, Artemis 1 launch notwithstanding. We are hoping to do another session that will be more of an outbrief. This is only an hour. We know we're not going to get all our questions answered today, but that we'll have a longer period of time on May 10th to go through some of these things in much more detail. We are also anticipating an ISRU one in June. And Clive, if you want to give an advertisement, feel free. Yeah, please come on up. Sure, why not? Quick.
First slide, please.
No slide. No slide.
Oh, okay. So this is a way to sort of what's next for ISRU on the moon, and what we're going to do is to have a session that is defining a lunar resource evaluation campaign. And how are we going to do that? What sort of things do we need to know in order to then understand what we have on the moon, such that they can be used to have a sustained, whatever your definition of that is, human presence there that will enable a long-term presence and sort of bring in the commercial side. And then the future one would be to how do you then implement this campaign? And they sound very similar, but they're really not, especially when you talk to international partners. So this will be the first one will be in June, and we will be defining a lunar resource evaluation campaign, and then we will get into the nitty-gritty in a later session. But we need to think as a community on how to use resources and actually understand if we have reserves. And there's a subtle difference there. So thank you.
Thanks, Clive. And there should be an abstract call coming out reasonably soon, correct? Okay. Yeah. And we will continue to have these sessions. Like I said, this is the main way that we are getting information from the community. So please do participate in them. We really do appreciate all of your participation.
So that brings us to the end of the presentation. So we did want to save plenty of time for questions here. Talked a little bit about this adventure, and this is intended to be an ongoing dialogue, not just us talking at you every once in a while. This is a dialogue. We mentioned we need your help, okay? But I do, before we turn over to the community to ask us questions, I want to take a few seconds. Just for a second here, stop and think about what we're talking about, okay? This is a tremendous moment. Every one of you in this room right now is talking about developing an Artemis science team. When is the last time that we did that? It's quite some time ago. This is exciting, whether or not you were part of that Apollo mission, whether or not you were present when they brought those samples back and opened up the last batch, whether you saw it happen as a kid and it motivated you to do what you do today, or like myself, you've only heard about it in lore from your colleagues who were there before you, okay? This is a tremendous moment. If you're sitting in this room, if you're online watching, if you're watching it in the future, it's you count too. What we would like to do is not have this be a handful of haves and a whole bunch of have-nots. All of you are a part of this Artemis effort, okay? All of you have participated in and or we hope will participate in these activities, new activities. Tell us what we're missing, okay? That's what our job is to figure out how to do this. It's not easy. This is not Apollo. This is not ISF. This is not shuttle. This is Artemis. It is different. It is brand new. It's complicated. And we're doing things, some of these things we're doing for the first time. We've learned a lot from all of that work. As Sarah said, we are certainly standing on the shoulders of giants, but this is new and it's exciting. And I hope that you all understand how exciting this is. So I just wanted to take that brief moment here, make sure we all kind of take a breath and breathe this in, because this won't happen again, what we're doing right now today, okay? So with that, I think we're gonna ask Deborah Needham to come on up here and we're gonna start answering some questions or listening to and trying to do our best anyway. But we're also taking a lot of notes here. Part of the teams that we've talked about are here today, helping us get all this captured, because this will help us sculpt the way we do this moving forward. And please, you know, be kind. Be kind to each other, okay? We're not competing here. All of us are supporting, all of us, okay? Be kind to each other. Be kind to the people around you. Even if you are on competing teams, be kind to each other. This is not a one winner only kind of thing. We have to work together for this to be successful over the long run. So be kind to each other, talk to each other. We're getting a chance to start seeing each other in 3D. It is really nice to see all of you out there, even if you got tough questions. But this is how we learn how to do this right. We're gonna make mistakes. There's gonna be bumps. Be kind. Have faith that we're all trying to get to the same common goal here, and we'll get there. Okay, we will get this worked out. But Deborah,
Thank you.
All right, thank you, Jake. Thank you, Sarah, for so much information. I know a lot of you are going to digest a lot of this before you come up to the mic. So as you come up with your questions, please do come forward to the mic. While we wait for you to make that trip, I will cover a couple of questions that we have online. So first, this is a question for Jake. What kind of vehicle will the human landing system be? Small like an Apollo LEM or huge like a SpaceX Starship?
well, there's a number of ways to answer that question, because there will be a number of solutions. We are not picking one single human landing system for the duration of all Artemis activities. So it may be both of what were described in the question, and it may be other creative ideas that we haven't yet seen. We did select one lander with option A. So SpaceX will deliver a lander and they'll be able to deliver our astronauts to the surface. But that does not mean that we're locked into only that solution moving forward. And again, stressing that the success of Artemis will depend on the creativity, ingenuity of the folks who are proposing these technical solutions. So we're going to pick the best of the best. Again, we work to set those requirements, but we're going to need to really lean on folks to bring those great ideas forward. So unfortunately, there's not a simple answer. Option A, we know what it is. SpaceX won that bid. They'll deliver a lander, but the landings after that will be by an yet to be determined organizations that build those.
Thank you. Jacob, go ahead.
Thanks, Deborah, and thanks, Sarah and Jake. I'm Jacob Richardson, NASA Goddard Space Flight Center. My question to you two is, what's your vision for the fact that we're going to have one science team and we're also going to have multiple competed science instruments? So what's your vision of how they will integrate and how they'll collaborate?
Yeah, we're working on that. Part of that role is part of our internal team will be there to sort of help those teams merge together and make sure that the needs of both teams are being met. If there are conflicts between them, as we start, doing things like allocating crew time, whenever there are things that may need to be negotiated, we'll make sure that everybody gets their needs met. And so there'll be some amount of that, but I do expect us, I called it the Artemis Science Team, right? We are one team, right? And so we're all gonna work together, to get the most science out of each one of these missions. So there will be a lot of collaboration, I imagine, between them.
Thank you.
Just one other thing to add to that is, remember, Right now, we're focused on this first mission, Artemis 3. But as Sarah mentioned, there will be additional landings after that. And so we are going to learn through Artemis 3 probably how to improve this process. And at some point, we'll get into a cadence. There will be science teams that are conducting operations while we're selecting science teams for missions that are several years into the future. And so, you know, that's hard to keep track of, but understand that there will be a cadence of this. So although this is what it will be for the first one, there will be a process that includes a much larger group of people thinking about missions into the future and operating missions now. So we'll, you know, that's going to have to flow, and how we integrate that together is something that we're going to have to learn with you all as we move through it. But that's kind of the best we've got right now.
Hi, Hannah Sargent, University of Central Florida. So you were mentioning earlier that you need everyone involved. So my question is to Sarah about these science teams and participating scientists. How involved can the international Artemis partners be in this? Is it limited to US citizens? How involved can everyone else be?
So I can't say about the participating scientists because we actually haven't thought that through, but we do anticipate that for the science team call that we will allow collaborators from foreign nationals, probably not as PIs, but as team members. I think there may be, ultimately some limitations on, whether they can, sit console or whatnot, but otherwise I'd see no problem with having international team members as science team participants.
Dave?
Hi, Dave Blewett, Johns Hopkins Applied Physics Lab. My question is about the two new instrument opportunities, the Artemis deployed and the terrain vehicle instruments. I was wondering what TRL you have in mind, and whether there might be a new DALI-like instrument development program to help feed instruments into those flight opportunities.
Well, so DALI is our program to feed instruments into those opportunities.
Well, isn't that focused a bit more kind of on commercial landers? I mean, having to have something that an astronaut is going to work on is a kind of another,
No, those sorts of things will be eligible in DALI as well.
Okay. Expect to have any boost in the DALI budget?
He's shaking his head. So, what was the other? I already forgotten your first question. Sorry.
The TRL for the Artemis deployed and lunar terrain vehicle.
So similar to our CLIPS calls, right? You're going to have to be able to make the deadline, right? And so the TRL is less important to us than whether you can be ready in time to launch.
Parvati, go ahead.
Thanks, Deborah. Hi, Parvati Prem, APL, and Jake, Sarah, thanks for really informative talks. You answered most of my questions, but I have one, and it's so nice to see you in person. And so Kristen Bennett and I were co-chairs of the Inclusive Lunar Science Workshop. So I feel like I should say this since everyone's taking notes, but don't mean to put you guys personally on the spot. Lots of respect and affection for all of you, and it's so nice to see you in person. But yeah, so Jake, I really appreciated what you said about the historic nature of this, and how important it is for all of us to work together and be involved in this. And so, that said, like I have noticed in some of the public outreach about this on social media and stuff, there's been a real effort to sort of highlight the range of people, different backgrounds and experiences who are involved in Artemis as a whole. And that's really appreciated. But I think, from my standpoint, when I look at sort of the science and engineering leadership, so, whether that's the amazing internal science team, so glad to see those amazing folks there, or the PRISM PIs, certainly the commercial partners, when I look at a lot of the visible face of the Artemis program, it is diverse in some ways, but there are some ways in which it really is not diverse. And so yesterday, we had the first ever Advancing Inclusion, Diversity, Equity, and Accessibility in the Planetary Workforce session at LPSC, which was awesome. The session chairs were great as well. I was one, but there were lots of really good ideas in there about doing field work in an inclusive way, and about supporting different career pathways. I hope that you guys will take all of those into account. And I think my question is, we also heard at yesterday's session about ways in which we could really make this happen. So for instance, there was discussion around the importance of providing funding for workforce development, educational outreach, something I wrote down that I can't read, but also, factoring this into team selection, things like that. So, is there a discussion sort of within beyond SMB about making sure that there are resources available to do this and that there are people who are really actively thinking about these things? Sorry, that was long, but.
I mean, we do discuss it, and that's why we were very happy to have an LSSW on this topic. We're glad that there's an LPSC discussion on this. I think it's important that you continue to discuss this and bring this up. The whole reason we have the LSSW is so that we can point at something to say, this is why this needs to happen. Yes, we talk about it, and many talk about it. I would say that it is a topic that is involved in many of the decisions we make. And certainly, I agree with you that maybe it's not as diverse as it could be, and we're working on that. I think to do your actual question, yes, it is a topic of discussion we have, but I think the most important thing is to keep having the discussion so that we can point to that and keep working on it. So I know that that's not the greatest answer in the world, but we are trying, and please be present and please participate so that we can keep that conversation going.
Yeah, thanks, Jake. And I'll channel one of our speakers from yesterday, Julie Rathbun. Discussion's great, but I think also there need to be resources from this. I'm not sure where it comes from, but I see important people in the room. So this is historic, and it is important that people are visible, because there have always been a diverse range of people involved in the lunar program from Apollo days, but some of them haven't been that visible always. And so this was a very important question. I'm glad I asked it. But thanks.
Thanks, Parvati. I'm going to take a quick question from online. All right, updated. Okay, so what will the follow-up mission be for LRO? And will the new spacecraft include a hyperspectral imager to produce a complete mineral map of the moon's surface in support of ISRU?
So yes, we are aware that LRO isn't going to last forever. The league right now has an activity going to sort of understand what our needs are, and I think I can speak for Joel when I say we're very interested in seeing the results of that activity, and so I can't say for sure whether it will include that or not, because we are waiting to hear from the community and what the community thinks those needs are.
Excellent, thank you. All right, come back to the room.
Hello, Adi Susic from University of Central Florida. I have a similar question as my other colleague from UCF, but currently we have ESA, JAXA, CSA on our international collaborators. And I suppose currently the political climate is a little bit abrasive for it, but are there any plans for Artemis to incorporate others who have planned out to go and have manned missions to the moon, such as the Indians or the Chinese or the Russians, and if there isn't, is there any pathways for those who wish to participate anyway to kind of join in?
Yeah, that's a great question. And I guess the earlier question was a little more focused on the science team itself. And this is a more broad question about the agency as a whole. And what I can say is that NASA is engaging with multiple agencies. We are not the only agency that has plans to go to the moon. So the good question you're asking is, do a whole bunch of agencies do it by themselves individually, or do we work together? I hope that the message I said before the questions started, it's not just about us in the room here. That's kind of a global statement. We do engage other agencies, and we are well aware of the plans that they have and looking at ways that as our architecture develops, they may participate as well. Just like I mentioned, our commercial partners and their creative and ingenuity, the international partners are the same for us. They have all kinds of ideas. We often get asked questions about, well, you didn't describe the details of this element or that base camp, or, and that's because we will develop that plan in partnership with the partners that are willing to work with us. So we can't tell you exactly what the charts on the far right or in the bottom right-hand corner of the charts we show, what that looks like in its entirety. We need to depend on that partnership. So the quick answer, that was a long answer. Quick answer to your question is yes, we are engaging international partners. The question Sarah answered earlier was about whether we can have international participation on the science team specifically, but as an agency, we are most definitely engaged and talking with those partners.
Thank you.
I'm realizing I should also introduce the online questioners, so I apologize for the previous two questions. Questioners. Gavin Tolometti asks, are there plans for field analog work that will help improve real-time in-situ analysis and sampling decisions during Artemis EVAs and robotic sample return missions?
So we talked a little bit in our slides about some of the analog and field activities and testing activities that we have underway. Many of those are in partnership with SMD, and in fact, SMD funds a number of those activities. And quite commonly, in situ field measurements is a topic. So there are a lot of creative activities inside NASA, but also competitively selected by SMD outside of NASA that's working on that. So yes, we are definitely looking at in situ approaches to sample collection, sample characterization, as we talked about earlier, how to curate these samples, how to make sure we preserve their integrity for future analyses. That whole spectrum is part of what it means to collect a sample throughout Artemis.
Excellent, thank you. And I was just reminded we have a couple overflow rooms, so I want to make sure that if we have any questions, let's start with ballroom 5. Are there any questions in ballroom 5? And any questions in ballroom 6? All right, excellent, thank you. We'll come back, Shwai.
Hi, this is Shwai from University of Hawaii. I have a question about the analogs. So why is limited to desert? I mean, it's so dry. So have you think about like an ice-rich region in the polar region? I mean, we identify several locations in Hawaii, like, it's kind of like a permafrost like a regolith, and also nearby is a desiccated line, and also is organic free. Do you think it's a good idea to propose?
So the analog that we are most interested in is not the physical analog, it's the operational analog. And so we'll go out there, it is convenient, it is easier to get to than some of the other more complicated places. It's a place we've been a lot of times, we have support from the USGS. And so there's a lot of good reasons why we go out to Arizona, but the main goals that we have there are operational, right? Understanding how to operate your science back room, understanding what it means to drive around to a location and get out and do some geology and get back in and drive to another location, those sorts of operational activities. And so the rocks themselves are not that important.
Okay. So there are still no plan for science analogs.
Correct.
Okay, thank you.
Although I will note that through some of the other activities that SMD funds, there are a number of activities in ice-rich locations. For instance, one of the images that we had up there was a group of people collecting samples in an ice-rich environment in Iceland. I know that through some of the survey funding that we jointly support, there are groups that are focused on ice-rich terrains. So we do have a variety of activities underway in icy environments as well. But that's a different call that I would hope you would apply to as well. But that's not what this one is here.
All right, thanks. I'm going to go to Carly Peters online. She asks, right, specifically after 50 years of technology development, there are increasingly capable tools. What modern tools are or will likely be planned to be used during Artemis?
So we're going to be fairly limited on Artemis 3. Set your expectations now. But as Jake was saying, right, this is the start of a program, and you're going to get more and more complex capabilities as we go along. And so, we do have a number of programs where we're testing in-situ tools and whatnot. And so I expect that as we move through further out in the Artemis program, we will get a lot of those great tools onto the surface.
And I think another important aspect to think about is just, for instance, we had some pictures up here of folks testing out suits. I mean, the suits will have tremendous capability advances in the mobility they offer, being able to move around with enhanced mobility capabilities, whether or not we can build small sensors and sensor suites into those as part of the vehicles themselves, the suits themselves. Carly's question is a question we ask almost daily. And that's the process here, is trying to figure out that trade space and what is the best solution that will get us the most science back. Have you seen the pictures of the lander? I mean, that's some new technology right there. It's some cool stuff.
All right, I'm cognizant of the time. I think we are approaching or just after the time. So can we take one more question in the room? And then
Waterway 5?
Yes, we can have one question from Waterway 5. For those of you who haven't asked your questions, please come forward after the session and we'll happily, yes, we have to, not in the room,
We'll
but out in
stand
the
out
hallways.
there.
Yeah,
You
we'll
can
stand-
talk to
we'll
us so
stand
we
out in
don't
the
disrupt
hallway.
what's going to happen. Exciting stuff happening in this room afterwards.
Okay, go ahead, Waterway 5.
Hi, this is Amanda Hendricks. Sarah, I wanted to follow up on your statement that things will be limited for Artemis 3 science. Can you just say a little bit more about what you mean by that? What are the limiting factors? And sorry if you said it already during your presentation. Oh, by the way, my other question is, are your slides going to be available?
Yes, I believe this is being recorded, so the YouTube link will
YouTube.
be there, so you'll have them. Renee tells me you should go to her talk tomorrow, and that will help answer some of your questions. But a lot of this is just that all of this is new. We're testing out all new systems, right? And so you're always very cautious on your first go out, and so we are limited by a number of different components, particularly on Artemis 3. But it will improve. Jake probably wants to say something more.
Yeah, as with every mission, there are constraints. There will be constraints on mass and power, volume, time it takes to do some of these activities. We have to work all that out, and we are working that out right now. I work with Julie Robinson on the exploration side. We have a group that we have in collaboration with Science Mission Directorate and Space Technology Mission Directorate called the USIG, which stands for Utilization Coordination Integration Group. And so our job is to answer these kind of questions. Well, what kind of work can we do? How much can we take? And as Sarah said, and I kind of said earlier, this is the first of a campaign of missions that is going to the moon. And we will learn and we will continue to grow and develop. And at some point, we'll get to a point where some of the things we already took will still be there and we can keep using them. And so we have to kind of push back a little bit on this urgency that, 3 decades I've wanted to get this widget there, and we'll get it there eventually, but we can't get all of it there on the first mission. So we do have to think a little bit about those constraints. And so, it's the same constraints you have on any mission, and we're going to learn a lot from the first flight, and we're going to develop, and Julie and I and Sarah and a bunch of other folks from SMD are in those meetings trying to advocate for as much as we can get on the science side. So, and that's our job, and we're going to keep doing it. So keep telling us through these workshops what it is you think you need to have there. What are the capabilities you want to see so that we can look for ways to get them built into that sequence of missions over the next many years.
All right, thank you very much, Jake and Sarah. And please do clear out the room so we can reset for the next talk.